Good morning, students. Continuation of the problems of ray optics and geometrical optics. Next problem 36. Previous class we stopped at this problem. A prism has a refractive index √2. Prism material it means. And refracting angle is 30 degrees. That means angle of refraction it is. Refracting angle, not angle of refraction. Careful with the term. Refracting angle means the angle of the two refracting surfaces called as the angle of the prism. And one of the refracting surfaces is polished, means made perfectly smooth so that light it behaves like a mirror, it means to say. Polished, making perfectly smooth, and also instead of that you may be given it as a silvered. A beam of light incident on the other refracting surface. Two refracting surface, one surface is silvered, other refracting surface light is falling, and after falling on the second surface it is retracing the path. A beam of light incident on the other refracting surface will retrace the path if the angle of incidence is first surface angle of incidence we have to find out. Angle of the prism is 30 degrees, n equal to √2, and angle of the prism is equal to sum of the inside angles of refraction R1 plus R2. This formula you need to remember. Next is R2 is 0 because light is falling, light is reflecting retracing the path. If the light is falling normally at the surface of the mirror, then it comes backwards in the same direction. I is 0, angle of reflection it becomes equal to 0. So here angle of refraction R2 is equal to 0 inside, that is actually incidence angle, also we can take I2, but I2 is outside, it is not going to the second surface, so we take it as a coming back angle is R2 is equals to 0, and A equal to R1 plus R2 means simply R1 we have to take. A becomes equal to R1 if light is retracing the path from the second surface. They may give this prism even sometimes like this also, or any shape, doesn't matter. Check up that point. This is going to be angle of the prism. Light falling here, falling on the second surface, normally again retrace. But normally means don't take 9 degrees please, it is a 0 degrees because with angle you have measured with respect to normal only. A equal to R1 plus R2, R2 is 0, therefore A equal to R1, that is already given 30 degrees. Next from Snell's law, sin I by sin R. If there is an IR you can take, or I1 R1 we can take, that is left to your choice. So I1 by sin R1 is equals to N2 by N1, it is air, this is N2. If any water is given means you take it as a N glass by N water. Sin A by sin R equal to N of the material by 1, it means for the air approximately 1. That value is given as √2 refractive index, and sin R1 is 30 degrees, therefore sin I1 is equals to √2 into sin R1, sin 30 is half. So √2 into half is nothing but equal to 1 by √2. Sin I1 is 1 by √2 means I1 is supposed to be equal to 45 degrees, that is the angle of incidence on the first surface. On first surface or first refracting surface. Next problem is 37th. In figure find minimum refractive index of the material. This material refractive index. Light is falling here and a total inter-reflection is taking place on this. This is called right angled isosceles prism. Here it is 9 degrees, 45 degrees. So whenever it falls here, this is a normal. With respect to normal, angle of incidence will be the same angle. You will get 45 degrees. Here also 45. So total deviation becomes equal to 9 degrees. Light is deviated and again deviated coming backwards. Retracing path means this total deviation will be reverse, means 180 degrees. Right angle prism is used to invert the erected images, or erected images can be inverted, or inverted images can be erected, and also can be deviated by 9 degrees. It can also be used to deviate by 180 degrees. Here it is deviated by 180 degrees. Here in this case, what is the minimum angle, minimum value of the refractive index you are asked to find out. Minimum value of refractive index is corresponding to the critical angle condition. Critical angle means if you are taking the sin C, if I is equals to C, just above C, then the light will be reflected backward, otherwise it will be grazing the surface. So sin C is nothing but equal to 1 by N. C is the critical angle. C is equals to critical angle for total internal reflection. It is nothing but equal to rarer medium by denser medium. N rarer by N denser. That means it is traveling from the glass to air. This is the air. Air is nothing but equal to rarer medium. That means it is N air by N material. It is N medium. That means 1 by N only. N air is equals to 1 we take approximately. And C must be nearly approximately equal to angle of incidence, that is equals to 45 degrees minimum conditions you taken. then you will get this n is equals to sin 45 equal to 1 by n, but sin 45 is 1 by root 2. So n required is equals to root 2. This is a minimum value. It can be anything more than this values. Root 2 means 1.414 also. Next question, 38th one is related to the concept question. In this they told is convex lens. Convex lens material has a refractive index equal to 1.5. It may be made of glass or something, whatever it is. But I mentioned it as a glass, so you can take it as a lens material. And surrounding medium, this is a medium, surrounding medium has a refractive index NL I mentioned, or N1, N2 also you can take, that is left choice. L is for the liquid. I am taking that liquid, but need not be liquid. Is equals to 1.6 mentioned. That value is more than the material, lens material value. Then it acts as it is a convex lens, means converging lens. Where focal lens maker's formula is 1 by focal length in the liquid is equals to n glass by n liquid minus 1 into 1 by R1 minus 1 by R2. In case if you are taking this Ng greater than NL, this becomes positive. Convex lens focal length is positive values. If that remains as a positive, means the glass refractive index should be more than that of the surrounding medium refractive index. If the lens refractive index Ng greater than NL, then it is behaving as a convergent lens, right? Ng glass greater than NL, F remains plus, it remains as a converging lens. Converging means convex lens. If Ng is less than NL, Ng less than NL means this becomes equal to negative. F becomes equal to minus, means already it is convex but behaves as a concave lens, means called as a diverging lens. Convex becomes equal to concave. But if Ng equal to NL, both have the same refractive index, what happens is it neither converges nor diverges. It acts as a plain glass plate. Then focal length is infinity. Light rays coming parallel, it just go parallel. It is called as a plain glass plate. It behaves as. So in this case what they mentioned is Ng is less than that of NL. So surrounding medium has more refractive than the lens refractive, means the converse lens behaves as a diverging lens. Answer is 2. Next question, convex or concave, then you take it as a convex. They didn't mention which side direction light rays are passing. Always take a by default from left to right side light rays passing. So this whole thing is a transparent material. Our refractive index equal to N2. The surrounding medium is N1, that is 1 for air. We take it is mentioned. A spherical convex refracting surface has a radius 12 centimeters. So not mentioned means you take it as a right side positive only. Its radius is nothing but equal to this radius. Is equals to 12 centimeters, which is positive. This is a center of curvature. If light is incident in air, n equal to 1, and is refracted into the medium having the refractive index equal to 2, this is n2 is equals to 2. Refractive index of the medium is 2. Light incident parallel to the central axis focus at the point. So we are taking the paraxial rays only, please, always. Incident in the first surface where they are going to meet. That point they want to ask. So this is U. Parallel rays means U equal to infinity. Parallel rays. Object at infinity you have to take. This is the pole. This is U and this is going to be V. V we have to find out. V equal to how much? For the spherical refracting surface, what is the formula we have is N2 by V minus N1 by U equal to N2 minus N1 by R is the formula we have. In this case, first medium is called the incident medium, or the object space where the object is lying is incident light rays. The place the incident light rays are there, it is called the object space. Where the image is supposed to form is called the image space, that is related to the image distance. So n1 is 1, that is air, approximately equal to, and u is infinity, n2 is 2, r they mention it as r is equals to 12 centimeters. It is right side, therefore we have to take it as a positive. 12 centimeters, it is on the right side in the direction of light rays. Substitute the values into this, and V we have to find out. N2 is 2 by V minus N1 is 1 by infinity is equals to 2 minus 1 by 12. 1 by infinity is 0. So what I get is 2 by V is equals to 1 by 12. So V is equals to 24 centimeters. It is positive, means right side. It is image is falling on the right side. A solid glass sphere is taken and light is incidenting. This is the diameter part you can take. Light, always remember the line, any line passing through the center of curvature is normal to the surface. Light is incident here at angle equal to alpha, angle of incidence it is. And this is supposed to be taken as a normal. It itself is normal. With respect to normal, you are measuring the angles. And light traveling from air to this air to this glass or denser medium deviates towards the normal. So it is going like this. After falling here, it is going in this way. After falling here, again you take the normal. Normal is a line passing through the center always. So this is also normal way to take. After falling on this place, it is again going from denser to rarer medium. Denser to rarer medium means it is deviated. This is a normal, sorry. Supposed to go straight. Like this, it is deviated and falling on the surface. Normal, and again it is been deviated toward away from the normal. If it is alpha, symmetrically, this is also alpha, this is a beta with respect to normal, this is also supposed to be beta. Extend backwards, this is supposed to be deviation d1, this is also deviation equal to d2, but symmetrical diagram if you mention means it is a sphere. Therefore, if you take the symmetrical angles, angle of incident refraction are same values if you have taken, then total deviation equal to sum of the two deviation. Deviation is also equal, you have to take. Diagram not perfectly drew here in this case. Little more angle if I take, I would have got it properly. This is going to be total deviation d. This is the d1, this is supposed to be equal to d2. d1 equal to d2 condition. So, you get what is deviation is alpha minus beta is equals to alpha minus beta. External angle is equal to external angle is equal to sum of the internal opposite angles for this triangle. Then d equal to d1 plus d2. They are asked to find out is find in the ray of light falls on the surface of the spherical paperweight, spherical paperweight, making angle alpha with the normal, and is refracted in the medium at angle beta. Angle of deviation of the emergent ray from the direction of the incident ray is how much? It is spherical glass ball. Alpha is angle of incidence, beta angle of refraction. Find total deviation. Total deviation is equals to deviation for the each surface is alpha minus beta. Deviation for each surface is d1 is equals to deta equal to alpha minus beta. Symmetrically we are taking, so whatever comes here, same thing we are taking here, coming and going. Total deviation d equal to d1 plus d2, which is 2d1. D equal to 2 times alpha minus beta is the answer. Next 43. This is related to the concept question. What they done is R1, R2 are the radii of curvature of the double convex lens. What they given is double convex lens. Double convex lens R1 and R2. N is the refractive index. Radii of curvature double convex lens with more power. Which are in options given for us? Which has a more power? Which combination has more power? From lens maker's formula. Okay, I will give you the options. R1 20, R2 10. 20 centimeters, R2 is 10 centimeters. Second option, R1 is equals to 20, 20. R1 equal to 20, R2 is also 20 centimeters. Third one, R1, R2 equal to 10 centimeters. Fourth one, R1 equal to R2 equal to 5 centimeters. Less is the radius, more is the less focal length and more focal power you will have. Lens maker's formula. What is lens maker's formula? Is power. Focal power is equals to reciprocal of the focal length is equals to n minus 1 into 1 by R1 minus 1 by R2. But R2 is left side radius, so it is going to be minus. Minus into minus becomes equal to plus. So only for the convex lens what happens is this is going to be minus. R2 is equals to minus. This is general formula. Double convex. If they mention equiconvex means R1 is equals to R2. For double convex, R2 is minus. The result is power equal to 1 by f into n minus 1 equal to n minus 1 into 1 by R1 plus 1 by R2 becomes for the double convex. Now, if R1, R2 and R2 are coming the denominator, if R's are less, F is less, but power is more. So, they asked is more power. More power means less R1. Among the given options, you have to check out which can give the less ones. Here 2, 1 more or less are there, but the lowest you go for this is possibility 5 centimeters. 5 centimeters, 5 centimeters is the lowest we can take. So power, focal length is less means power is more. The option is fourth option you have to prefer. 44. Two thin lenses when in contact produce a combined power is 10 diopters. I will give the hint for this. Two thin lenses. Always you have the not mentioned also take it as a thin lenses, unless specifically mentioned as a thick one means you take it as a curved surfaces. Curved refracting surface formula you have to use if you have separately for surface, second surface where you given thick lenses. But for CET purpose like that they don't give. Two thin lenses in contact has a power 10 diopters. In contact has power equal to plus 10 diopters. When they are 0.25 meters apart, power is plus 6 diopters. If the separation is 0.25 meters, the power is P2 equal to plus 6 diopters. Power is plus 6 diopters. Find F1 and F2. Find focal lengths F1 comma F2. First case, in contact they mentioned. In contact. Contact means D is 0. When you are taking the two thin lenses F1 and F2 in contact, D is 0. The resultant is 1 by F is equals to 1 by F1 plus 1 by F2 is power, that is P1 is equals to 10 diopters. Next and in SI units only we are taking place. In SI system, power you mentioned means all units must be in SI system. And with separation, D is equals to 25 centimeters or 0.2 meters means one lens is here, other lens is here. D, this is F1, this is F2. Separation is there. Resultant focal power is positive only given 1 by F2. Sorry, F will take it as a F prime. Power 2 is equals to 1 by F1 plus 1 by F2 minus D by F1 F2. This can be written as P1 plus P2. P1 plus P2 is equals to 10, one relation. This is P1 plus P2, this is given as equals to plus 6 diopters. P1 plus P2 minus D into P1 P2 is plus 6 diopters. Solve these equations, P1 plus P2 substitute here, and solving these two you will get the expression for P1 is equals to 1 by F1 equal to how much? P2 equal to 1 by F2 equal to how much? Then you find out F1 equal to how much? F2 equal to how much? One you find out means other one you can easily find out from the given options. The answer for this is 0.125 meters and 0.5 meters. Answer F1 0.125 meters, F2 is 50 centimeters means 0.5 meters. Please work out that by yourself, I am leaving it to you. When they mention concave lens means take the focal length as negative, focal power as negative. Here they didn't mention plus minus, just lens mentioned. So result you have to check out. If they get the focal length as positive, power positive means convex lens, and negative means it's supposed to be concave lens. We stop here.